So thus far we've done ionic naming and covalent naming. Remind me of the difference between ionic and covalent.
Ionic is metal and then covalent.
Ionic is metal and nonmetal. Good. Covalent is two nonmetals. Okay, covalent has two nonmetals. Which one of these systems uses the prefixes? Covalent. Okay, so they use those prefixes that we looked at in your book. All right. We're going to move on today to learn how to name acids. Okay? So, what are some characteristics you can give me about acids? Yeah, they're acidic, yeah. Francis, what do you think? Yeah, they have a low pH. They have a low pH. What else do you know? Yeah.
Don't they like emit some ion H?
They are proton donators. Okay, we consider acids proton donators. Okay, or they can be considered electron acceptors. Whichever way you want to look at it. So when we talk about donating protons or accepting protons, what element do you think we're talking about? What element only has one proton? Hydrogen. Okay, so essentially they're hydrogen donators. Okay, when we talk about protons in the chemistry world, we're talking about hydrogen atoms. Okay, so if I say they gained a proton, that means they bonded with another hydrogen atom. Okay, so that means these acids, if they're able to give up hydrogens, that means they have to be bonded with hydrogens in the first place, right? Hydrogen has to be part of their chemical formula. So when you're looking at naming an acid or putting together an acid, you have to incorporate hydrogen in there. Okay, so we're bonding hydrogen with elements, we're bonding hydrogen with polyatomic ions to form these acid compounds. Okay? Any questions? All right, we're going to look at two types of acids. The first of which are called binary acids. What do you think, just looking at this word binary, it means? It means two. Okay, so binary acids have two elements. They're made up of two elements. What do you think one of those elements has to be? Hydrogen. Okay, it has to be made up of hydrogen. And then they're typically made up of the halogens. What group number are the halogens? 7. They're group 7. Okay, so these are elements like chlorine, fluorine, bromine, iodine. Okay, all of those group 7 elements are really, really good to make acids with. Okay, binary acids don't always have to be with group 7 elements. That's just very, very common. Okay, the group 7 elements make great anions for our acids. Why do you think the group 7 elements do that so well? Yeah, Thomas.
They have a negative 1 charge.
They have a negative 1 charge and hydrogen has a positive 1. So they pair together really well. Okay, so anions with a negative 1 charge make really good acids, okay, because that anion wants a hydrogen molecule or that hydrogen atom or the proton very badly. Okay. The other type of acid that we're going to look at are called oxyacids. Yeah, so what does this mean that these acids probably contain? Oxygen. Okay, so we know they have to contain oxygen. We know they have to contain what else to be an acid? Hydrogen. Okay, so they're always made up of oxygen, hydrogen, and then some other element. And this other element is usually a nonmetal. Okay, so these oxy acids are most of the time formed with our polyatomic ions that we know. Carbonate, sulfate, phosphate, nitrate. Okay, all of those things are a nonmetal bonded with oxygen. Okay, all we do is add hydrogen to them and they become these oxy acids. Does that make sense? Okay. So, alright, so if we want to look at building an acid, we know it has to come from an anion and hydrogen. Okay, so someone give me an anion that we've been working with. Could be a single element, could be a polyatomic ion.
Sodium.
Sodium is not an anion. Sodium is a cation. Fluorine. Okay, so fluoride is the anion version of fluorine, right? Anions end in IDE. So fluoride, what's fluoride's charge? -1. Okay? If we want to make that into an acid, we need to pair it with enough hydrogens to make a balanced molecule. Okay, so acids have a neutral charge. That's important for you to know. Acids are neutral. Oops. Okay, so acids have to have this neutral charge. So if we have a hydrogen, that's a +1, and we have a fluorine or a fluoride, that's a -1, what would our molecule then look like? How many of each do we need to pair together? 1. Just HF. Okay, and the name of this acid is hydrofluoric acid. And we're going to look at a system of naming here. I'll give you a little cheat sheet kind of to help with our naming systems. Let's go ahead and start building some of these acids, okay? So I want you to first give me an anion. Okay, it could be a polyatomic ion that we've been working with. It could be one from the periodic table. Give me a different anion now. Carbonate. Okay, I heard carbonate. Carbonate is CO3. What's its charge? -2. Okay, this is carbonate. Okay, if I would like to make this an acid, I need to pair it with a hydrogen, which is a +1. Okay, so I do the same type of system I've been doing with my ionics. I just cross out the charges, and I'm going to bring those subscripts down. Okay, so then it's going to look like H2CO3. Correct? Does everybody see what I did there? All we're doing is showing that we need 2 of these +1 hydrogen atoms to cancel out this carbonate, which is -2. Okay, so if you look on your cheat sheet, you'll see that anions that end in ATE, what does their acid name end in? Ic. Yeah, it ends in IC, so ic. So the name for this molecule then is just carbonic acid. Yeah, you don't include the hydrogen in the name because this ic acid, this acid is telling us that it has hydrogen bonded to it. Okay? All right, what questions do you have here? Let's try a different type of anion now. Chloride, okay? Chloride is Cl, and what charge does it have? -1. Okay, if I want to bond this with hydrogen, which is +1, what will my finished product look like? HCl. So go ahead and look on your cheat sheet and tell me that, yes, things that end in IDE then have to start with the prefix hydro. Then we put the root of that element name, chlor, and then it ends in IC, and we add acid at the end. So we have hydrochloric acid. is what HCl is.
Phosphate.
Give me an anion that ends in ITE. Phosphite. Okay, give me the formula for phosphite. PO3 minus 3 is phosphite. Okay, in order to make this an acid, I need to pair it with hydrogen. How many hydrogens do I need to pair it with? 3. So it's H3PO3. Okay, so this is phosphite that we're working with here. According to our cheat sheet, what should the name of this molecule be then? Oh, I can't spell apparently. Phosphorus acid. Phosphorus acid. It's not just phosphorus acid, it's phosphorus acid. Okay, so we revert back a little bit to the phosphorus actual. Oh, I can't spell still. Sorry. Phosphorus acid. Is that better? Is that better? Okay. Sorry. So we have phosphorus acid. And that's what the word now says, I think. Phosphorus acid. Okay, so now do you think you could work backwards if I give you the name of an acid? Can you give me the compound? We'll see. Give me the compound of nitric acid. Nitric. All right, Braden, what do you think?
HNO3.
HNO3. Raise your hand if that's what you had. Good job. Okay, so if we look at nitric acid, we know that the ic ending means we need to have an ATE anion. Okay, then we look at this NO3 and that looks like nitrate. Okay, very good, very good. What if I give you chlorous acid? Chlorous acid. Go ahead and give me the chemical formula for that.
HClO2.
HClO2. Raise your hand if that's what you had. Very good. Okay, this OUS ending means we need to end in ITE. So we look for chlorite, which is ClO2 minus. All right, one more here. Give me the formula for hydrobromic acid. HBr. Good. HBr. Bromide. If we have hydro and ic, that means we're looking for bromide. Bromide is Br minus. We pair that with one hydrogen atom, which means we have HBr. All right, very good. Why don't you give me the name of this molecule? It's sulfuric acid. Okay, so this is one of those like phosphate. Yeah, the H2 is just given in our acid name. Okay, so when we have an acid, we automatically assume that hydrogen is bonded to it. Okay, so that's how we just count the H2. All right, so instead of sulfic acid, we include this sulfuric in here. It's just one of those naming rules like the phosphoric, like that. Okay? Naming bases is very simple. Okay, most bases contain what we call this molecule. What is this molecule? Hydroxide. Okay, this is considered a base because it's a proton acceptor. right? This is a base. Okay, because it wants a proton. Okay, that's what we call these a base. It wants to take protons. So most bases contain this hydroxide molecule. We name bases the same way we do as regular ionic compounds. Okay, so this is a really, really common base. What's the name of that molecule if we name it with just like our ionic normal rules? Sodium hydroxide. Yes, okay, that's it. Sodium hydroxide. Okay, that's it. Most bases contain this hydroxide molecule. You name it exactly the same way as we've been doing ionic naming. All right? Oh, sorry. We're going to do some practice now with ionic, covalent, and acids. Okay, so I'm just going to write a bunch of molecules up on the board, and you need to determine whether they're ionic, covalent, or whether they're acids, and you need to name them the correct format. All right? So let's see here. Go ahead and just do these in your notes. If I give you the name, just go ahead and write the formula. Okay, those 5. Go ahead and get these done in your notes. Dylan.
It's ionic. It is mercury sulfate.
Mercury 1 sulfate.
Oh, that's what I meant.
Oh, okay. Okay, so how do we know that it's mercury 1?
Because there's no number after.
Yeah, good. Jake, what do you think?
2 and the 4 lower to 1 and 2.
Yeah, exactly. The 2 and the 4 would lower to 1 and 2, or reduce. Okay, what about the second one? Who has the name for this one? Or who has the formula for this one? Hydrochloric acid. Jack. HCl. Perfect. Is that what everybody had? All right, good. Let's move on to the next one. Yeah, Thomas.
Selenium hexafluoride.
Selenium hexafluoride. Very good. Is that what we had? Yeah. It's ionic or covalent? Covalent. All right, let's look at our next one here. Who has it? Jake, go ahead. Close. It's carbonate. It would be carbonate if it had a charge. But this has no charge. So then we have to name it covalently. Francis, what'd you have?
Carbon trioxide?
Carbon trioxide, exactly. So I just put this in here so that you can see it's not carbonate if it doesn't have a charge. Carbonate's got to have that ion form. And what about our last one here? Caleb, did you have our last one? What'd you get? Lithium oxide. What about the Roman numeral? Do we need it? No. No Roman numeral for lithium because it doesn't take on more than one charge. All right. That's it.